Hello, this video is to talk about inequalities, how to graph them on a number line, as well as how to backtrack to solve them. First, we're going to review the signs themselves. So we have on the top, this is the less than symbol, this is the greater than symbol, this is the less than or equal to symbol, and this is the greater than or equal to symbol. One vocabulary word we're going to use today is called the boundary point. The boundary point is where you place your dot that represents the values within your inequality. I'm going to go ahead and demonstrate this now with these three examples. As you can see, this is saying x is greater than 12. Now there's infinite answers to this, so the best way to show the solutions to this is to go ahead and do it on a number line. So what I like to do is I like to find my boundary point. Now the boundary point for this is 12. So I like to do a 12 here and then do a couple numbers on either side just to allow the reader to see this more clearly. And then because there's no equal sign, you're going to have a hollow dot. And usually I put the number above the line so it doesn't kind of blend in with the number line below. And then it's all numbers greater than 12, so I would go this way. And again, anytime there's no equal sign, it's just a less than or greater than, you're going to use a hollow dot. And to check your answer, if I put in 14, obviously 14 is greater than 12, it does work. On this next example, my boundary point is at -4. And now remember, when you do negative numbers, make sure you put in the numbers on either side. They're getting smaller on the left and bigger on the right here. And then I'm going to go ahead and put, this time I have an equal sign. It's less than or equal to, so I'm going to put a solid dot on -4, and it's all numbers less than that. So I'm going to go this way. In this next example, it's where I have numbers on both sides. So that means that you're going to have two boundary points. You don't always have to count by ones. So in this case, I'm going to go ahead and count by twos, just so I can see all my values that are needed for this problem. And again, I always do a couple numbers before and a couple numbers after the boundary points, just so, again, the reader can see it more clearly. So on -6, because there's an equal sign, I'm going to put a solid dot. And on 10, I'm going to put a hollow dot because there's no equal sign here. And then you have three areas to consider. Well, -8 is not bigger than -6, so I'm not going to go here. And 12 is not less than 10. So the only numbers that are going to work are the numbers in between these two dots. And if I check one, if I try 0, 0 is definitely bigger than -6 and smaller than 10. So that's kind of how you check to see which way you have to go. Now there are instances when you do this that sometimes you have an arrow going in two different directions. We'll talk about that in our next lesson. The last thing I want to show you in this video is how to backtrack with an inequality symbol. Now backtracking is very similar to what we've done all year with backtracking with an equal sign. It's just you have an inequality. So in this first example, I'm going to go ahead and get rid of the adding and subtracting first. I'm going to go ahead and add 5 to both sides. So then I have 2x is greater than or equal to 8. And then I'm just going to divide by 2. So when I solve it, again, it's just like normal backtracking. It's just x is greater than or equal to 4. So if I did this on a number line like I just demonstrated earlier, I would put a boundary point at 4, and it's a solid dot because it has an equal sign, and it's all numbers greater than 4. So I'd go this way. Now to check this, I'm going to go ahead and put in a number that's over here. So I'm going to choose like 5. 5 times 2 is 10, minus 5 is 5, and 5 is definitely greater than 3, so that's why it does make sense, it works. So again, this next example, I'm going to subtract 1 on both sides. So I have 3x is less than 6. and then divide by 3. So I get x is less than 2 for my solution. So again, if I do this on a number line, my boundary point is at 2. And then I want to put, there's no equal sign, so it's going to be a hollow dot, and it's all numbers less than 2. So I'm going to go this way. And then I'm going to go ahead and choose a number to plug in to see if this works. I'll put it in 0. 0 times 3 is 0, plus 1 is 1, and 1 is definitely less than 7. So I know that is a correct solution. Now this next one you have to be very careful with. When it comes to backtracking, the steps are the same. If I have negative 2x is greater than or equal to 12 here, then I divide by negative 2. Now, what's very important is when you divide or multiply by a negative number, when you're backtracking, you have to switch the direction of your sign. So my greater than or less than, so my greater than or equal symbol is going to turn to a less than or equal symbol. So now I'm going to have x is less than or equal to negative 6. So once again, it's very important. Anytime you multiply or divide by a negative, your inequality sign has to switch to the opposite of what it is. Because think about that, when you multiply by a negative, you're turning all positive numbers into negatives and all negative numbers into positives. So you have to switch the sign. So if I go ahead and finish this, I'm going to put my boundary point at negative 6. Because there is an equal sign, I'm going to go ahead and put a solid dot at negative 6 for my boundary point, and it's all numbers less than that. So now if I check, if I put in negative 8 times negative 2 is 16 plus 8 is 24, which is definitely bigger than 20. Now if I didn't switch that sign, I would have got that wrong with my graph going the wrong direction. So I'm going to do one more example. This time I'm dividing by a negative. So the first thing I'm going to do is add 10 to both sides. So I have x divided by negative 3 is less than 24. So the opposite of dividing by negative 3 is to multiply both sides by negative 3. And I'm going to have x. Now because I multiplied by a negative, I got to switch the direction of my sign, which is negative 72. So then my boundary point is at negative 72. Put a couple numbers on either side of my line for time's sake here. It's a hollow dot because there is no equal sign on 72, and it's all numbers greater than, so I'm going to go this way. So again, going this way, if I chose like negative 60, which is over here, and check it, negative 60 divided by negative 3 is 20, minus 10 is 10, which is definitely less than 14, so I know this is the correct answer. And then the last example I want to share with you is sometimes you have an inequality like this where you have numbers and a variable on the middle, and when you backtrack, you just do whatever you do to one side, you do on both sides. So right now I'm going to add 1 and add 1. So now I have 10 is less than or equal to 2x is less than or equal to 18. Then when I divide by 2, I divide it by everything by 2. I end up with 5 is greater than or equal to x, which is, or less than or equal to x, which is less than or equal to 9. So when I graph this, I'm going to have two boundary points. So if I have, let's go ahead and label this real quick. So I have a couple numbers on either side at least. I'm going to put a solid dot on 5 and a solid dot on 9. And then again, it has to be numbers between 5 and 9, so I'm going to go ahead and connect this, as you can see, for my inequality.